So let's take our newfound knowledge of projectile motion in 2 dimensions as a vector valued function out for a spin, shall we? So you can tell that this is a 2-dimensional problem because it's got height and horizontal and all that stuff, but there's no third dimension mentioned. There's no crosswind, there's no downdraft, updraft, anything like that. So no third dimension in the problem. That's how you can tell you're in one of these ones. Okay, so that's great because these are easier than the 3-dimensional ones. So we have a projectile. It's going to start at some type of initial height, and it's going to shoot, initial height of 40 feet, and it's going to shoot at an angle of 45 degrees above the horizontal with an initial speed of 10.2 feet per second. All right, so we have this projectile going out like this. Boom, and it's going to hit over here. Okay, so let's think about some things. What is some stuff that we know from what they're giving us here? They're giving us an initial position right here. They tell us that starting at a height of 40 feet. So that means this right here is at 40, which if we write in a vector form is 0, 40. That's your x0 and your y0. That's your initial position, right? Initial position. All right. Then they also have this vector coming out, and then they're telling us that a couple things. They said that it's at an angle of 45 degrees above the horizontal with an initial speed of 10 square root of 2 feet per second. So the magnitude of this vector is 10 square root of 2. And that's from the horizontal. So there's a 45-degree angle right here from the horizontal, from the point that it was fired. Sorry, my line's not perfectly horizontal, but you get the gist. All right, so I need to come up with that initial vector. So let me just write these down over here. So we're going to make some notes. The initial position, which I already did, but that's okay, I'll do it again. It's x0, y0 is 0, 40. That one's nice and easy. And the other one's actually not too bad either, because this is in only 2 dimensions, right? We remember how to find a vector like that, right? So the initial velocity is u0, v0, which would be 40, or not 40, sorry, 10 square root of 2 times the cosine of 45, and then 10 square root of 2 times the sine of 45. We learned that earlier in the same unit. All right, now we know what the cosine of 45 degrees is. That's 1 over the square root of 2. So this is really 10 square root of 2 times 1 over the square root of 2. And the sine of 45 is the same, 10 square root of 2 times 1 over the square root of 2, because I remember my unit circle from pre-calculus. And so this is just going to be 10, 10. These end up canceling. All right, so there's my initial velocity. And those are now things I can plug into my position function. So r of t would be equal to u0, which is 10, t plus x0, which is 0. So there isn't anything there. Comma. Okay, now we need to take a moment. This is feet per second. So you have to remember back a page. Gravity in imperial is 32 feet per second squared. So we're just going to pop that value in there. So it's negative 1/2 times 32 t squared plus v0, which is 10 t, plus y0, which was 40. And usually we don't leave the negative 1/2 times 32. That's just kind of bad form. So this is 10t negative 16t squared plus 10t plus 40. There's your position function, r of t. All right, now they want a position, done. They want velocity. Well, velocity is just the derivative of this. So the velocity will be the derivative of your position function. The derivative of 10t is 10. The derivative of negative 16t squared is negative 32t, which incidentally is your gravitational constant, plus 10 plus 0. There's velocity. And then acceleration is the derivative of velocity. The derivative of 10 is 0, and the derivative of this is negative 32 plus 0. And on a side note, let's double check we understand our units. Position would be in feet. Velocity would be in feet per second. So I'm just going to put units over here. And acceleration would be in feet per second squared. Okay, next, they want us to find the position, velocity, speed, and acceleration at t equals 1 second. Okay, so position. Position would be r of 1, which would be 10 times 1, negative 16 times 1 squared plus 10 times 1 plus 40. Feet. So that's 10, comma, negative 16 plus 50, so 34 feet. Position done. Velocity. Velocity would be taking the velocity vector valued function and putting 1 into it. So that would be 10, comma, negative 32 times 1 plus 10, which is 10, negative 22. That would be feet per second. Speed is just the magnitude of velocity. And there's not really an abbreviation for speed. I guess you'd call it SP, speed. So I'll just call that speed at 1. So that would be the square root of 10 squared plus parentheses negative 22 squared. And we're just going to make a computer find those values for us and add them up. I mean, 10 squared is 100. So 22 squared is probably 400 and something. So let me find it. So if I want Maple just to find 10 squared plus 22 squared, it can do it, and it's 584. So I know it's the square root of 584, but of course Maple will simplify that for me and tell me it's 2 square root of 146. So I wanted a decimal approximation for that, and I don't currently have the math editor up so that I can get the approximate. So I just did it this way. So I just put in a decimal, and it tells me it's about 24.166. Okay, so that's my speed. My speed is the square root of 584, which is approximately 24.166 feet per second. Speed is, or has the same unit as velocity. Right? They're both feet per second. All right, what about acceleration? Well, acceleration is really easy because the only thing affecting this object is gravity, and therefore, right, I just need a of 1, which if you look at the acceleration vector, it is 0, negative 32, and that would be feet per second squared.